So in this video, we are going to review the 6 basic types of chemical reactions. What we need to be able to do after this video is, if you're given any chemical reaction, you have to be able to identify what type of chemical reaction is or what the products are going to be. So like I said, there are 6 different ones. The first one we're going to start with is a synthesis reaction. So a synthesis reaction occurs when 2 or more reactants combine to form one. So an example, if we just use general letters, would be in the form of A plus B, 2 different reactants combine to form one new product, C. So a real example with actual elements would be if you take 8 moles of iron, Fe, and you react it with sulfur, S8, you're going to make 8 moles of FeS. The reason we know this is a synthesis reaction is because if we look at the reactants, I have 1 reactant, 2 reactants, and in the products, I just have 1 molecule. So I've gone from 2 or more reactants, and I have formed 1 product. So this would be a synthesis. The word synthesis just means making. So we're just making something new. We're making 1 new product. Okay? Second reaction type we need to know is decomposition. Decomposition is the opposite of a synthesis reaction. This is when one complex molecule breaks down or decomposes into 2 or more other molecules. So an example would be if we have the molecule AB, and it breaks down into 2 components, molecule A and molecule B. This would be the general form for a decomposition. 1 complex molecule breaks down into 2. So if we looked at another example, if you take water, over time water is going to decompose into hydrogen and oxygen gas. We know that this is a decomposition reaction because if I look at my reactants, I have 1 reactant on the left. The number of moles doesn't matter, it just matters how many molecules, how many different molecules do you have. I just have 1 molecule, in this case, water. And on the other side I have H2 and I have O2. I have 2 different molecules, so I've gone from 1 to 2, so this is a decomposition reaction. Third one we need to know is called a single displacement, or sometimes also called a single replacement. What occurs in a single displacement reaction is that one atom, I should say, trades places with another. And this is almost always the cation. The easiest way to predict this is just switch the cations, which have a positive charge, so whatever atom or polyatomic molecule has a positive charge, switch what they're bonded to, and that's going to be a single displacement. So the general form of this would be AB plus C produces, A plus CB. Remember, in the way we write things, usually the first element is always the metal or whatever has a positive charge. So in this case, since A and C are written first, they're going to switch places. So now we can see that C is bonded to B and A is by itself. So actual example of this, if we took MgCl2 and we reacted it with lithium, well, find your 2 cations, find your 2 positively charged elements. That's magnesium and lithium. So they are going to switch places. So the products they're going to form are LiCl and Mg. Just to wrap this equation all the way up, you would want to make sure that it was balanced. So since I have 2 chlorines here and only 1 here, I need a 2. Now I have 2 lithiums. I would need a 2 there. So this is a single displacement. These elements are trading places and you have 1 single element by itself. On the other hand, we can also have what are called double displacement reactions. And the only difference between a double displacement reaction is you have, instead of a one single atom by itself, both of the cations are bonded to anions. The cations still just switch what they're bonded to, but in this case you have two molecules where you have cations and anions. So for example, the general form would be AB plus CD. And again, the first elements are usually the positively charged ones are cations. So these guys are going to switch places. So they're going to be double. There's two molecules getting displaced. So we're now going to have AD plus CB. So an actual example of this, CD. An actual example of this, let's say we took lead nitrate, PbNO3(2), and reacted it with potassium iodide, Ki. What are the products that we're going to form? Well, if this is double displacement, my two cations, in this case lead and potassium, are going to switch what they are bonded to. So I'm going to form KNO3, potassium is now going to be bonded to nitrate, and PbI2. Last thing you need to check is this balanced? No. I would need two KNO3s here in order to balance out this reaction. Again, double displacement is different from a single displacement because you don't have any elements by themselves. Here their cations are bonded to anions. In a single displacement, you just have a single element by itself. That's the easiest way to identify it. Fifth reaction type that we need to know is a combustion reaction. A combustion reaction is when you take a hydrocarbon, and this is a new word that we need to learn. A hydrocarbon is a molecule that only has carbon and hydrogen, where these X and Y's represent some number, some subscript. It doesn't matter what they are, but a hydrocarbon is any molecule that just has carbon and hydrogen in it. When you react a hydrocarbon plus oxygen, you produce carbon dioxide and water, always. That is a combustion reaction. So, for example, let's say we took C10H8. Well, if we react it with O2, we always know, if I look at this reaction, okay, what are the things I need to have for it to be combustion? I need to have O2, check. I need to have a hydrocarbon. Well, does this molecule only have hydrogen and carbon? Yep, so it's a hydrocarbon. So I know the products are always going to be carbon dioxide plus water. Now, the only thing that will be different, depending on the reaction you're looking at, is how it's balanced, the number of moles of each molecule. So in order to balance this, what would I need to do? Yep, I would need 10 carbons over here. Now my hydrogens aren't balanced, so I'm going to need 4 hydrogens over here. Now let's see, I have 24 oxygens, so I'm going to need to put a 12 here to balance it out. So this would be considered a combustion reaction. Anytime a hydrocarbon reacts with oxygen to make carbon dioxide and water. Last but not least, this is one that we've already done. Acid-base. Anytime you mix an acid with a base, you're always going to make the same products. You're going to make a salt and water. And remember, the word salt is just a general term for an ionic compound. Okay? Briefly, I want to refresh how to identify acids and bases. Acids usually, almost always, have a hydrogen in front. Okay? And the reason for this is because we know acids always dissociate into H plus and whatever's left over. So if we use the general form of an acid, HA, where A is any acid, any negative ion, we know this is going to dissociate into H plus and A minus. whatever A is. Bases, the easiest way to identify them, that what we need to know is if they have hydroxide, OH in the back. Okay? So we've learned about sodium hydroxide, you could have magnesium hydroxide. Things with hydroxides are basic. The one exception that I told you need to know in class is ammonia, NH3. You have to know this. Ammonia, you might look at it and not assume that it's a base because it doesn't have hydroxide. The problem is, all of these reactions occur in solution, in water. So really, NH3 is reacting with water, and when this happens, it produces NH4+. So one of these hydrogens gets ripped off onto here, and you're left with OH-. So actually, when ammonia goes in water, you produce hydroxide, which therefore makes ammonia a base. Okay? So you got to know how to identify acids and bases. You know when they react, they always form a salt, which is an ionic compound, and water. So let's go ahead and look at an example real quick. Let's say we took the compound H2SO4 and we reacted it with KOH. We want to figure out what type of reaction is this. Well, this first molecule has a hydrogen in front, so this is going to be an acid. It's going to dissociate into H+. Other molecule, we got hydroxide, so this is a base. So this is an acid-base reaction. I know I'm going to form a salt and water. So I can automatically just go write H2O. I know water is going to get formed. What is the salt going to be? Well, a salt is an ionic compound, so it's whatever positively charged cation and negatively charged anion I have left. So K and SO4. You just got to know your nomenclature. So that sulfate, SO4 is 2-, so I'm going to need to make this K2SO4. Now the last step would just be to balance this. So potassium, I got 2 on that side, I need 2 over here. I have 1 sulfate, looks good. And I think we are almost balanced. The one last thing that I need to do is 2 waters. The last thing you need to know is for a acid-base reaction, these are also called, we've learned, neutralization reactions. We'll get into more depth later in the year about what happens if it's not a strong acid, if it's a weak acid and a weak base, etc. But they always have the same net ionic equation. So if you're writing the net ionic equation for a neutralization reaction, for an acid-base reaction, and if you don't get that, you did something wrong for the net ionic equation. So you got to know these 6. You got to be able to identify them by looking at the reaction, the reactants, and you got to be able to predict the products.